All right, in our last lesson on writing proofs that prove triangles are congruent, we are going to go full circle. Back at the beginning of the lesson, when we first started this unit, we talked about CPCTC. And what CPCTC said was corresponding parts of congruent triangles are congruent. I was able to prove that these two triangles were congruent because all of their corresponding parts were congruent. So today we're going to take it and we're going to say, okay, I don't need all 6 pieces of the triangle to prove that triangles are congruent. I can prove triangles are congruent by 5 proofs: side, 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 angle, side, hypotenuse, leg, angle, angle, side, or angle, side, angle. I can use those 5, so I only really need to know 3 things about the triangle. But once I know the 3 things about the triangle, I actually know, once I prove the triangles are congruent, I know that all the rest of the parts are congruent too. So it is important that you understand what CPCTC stands for. Corresponding parts of's not, the O is not in there, right? That's what makes it hard. Corresponding parts of congruent triangles are congruent. You use CPCTC in a proof after proving the triangles are congruent. So our goal for today is to be able to prove that corresponding parts of congruent triangles are congruent. Okay, we're not going to know that all of them are congruent until the very end. So I want to use CPCTC after proving that the triangles are congruent. You have to say the triangles are congruent first before you can use the CPCTC step. So in general, without an informal, let's write an informal proof and let's look at this. So this says, for the problems below, write the congruent statement, give the reason proving the triangles are congruent, and make a list of the remaining parts that are congruent by CPCTC. Okay, so here's what's going to happen. DB is perpendicular to AC. So DB is perpendicular to AC. Perpendicular means that the angles are right angles. So that's what perpendicular means. So perpendicular results in the right angles. Then D is the midpoint of AC. So D is a point, and it is the middle point of AC. So D is in the middle of AC, which means that AD is congruent to DC. All right, so we keep looking, right? We've used everything in our given. We've got our right angles, and so now we've got congruent angles because right angles are all congruent. We've got congruent sides, but we need one more piece because I only have 2 things on each triangle, right? I have this, I have AD is congruent to DC, I have angle 3 is congruent to angle 4 because right angles are all congruent. I need one more piece. I look at my picture, and the easiest way to go is to use a reflexive property. It's not the only way to go, but it's the way that we're gonna do this. BD is congruent to BD because of the reflexive property. So I know that these 2 triangles are congruent. Which 2? I know that ABD is congruent to triangle CBD by side, angle, side. It's not HL, right? I don't have the hypotenuse labeled. So it's side, angle, side by the side, angle, side theorem. Now that I know that those 2 triangles are congruent, I can say all of the remaining parts are congruent. Only because I've said, now those 2 triangles are the same size. Okay? I already know those orange pieces. Now let's talk about all the rest of the pieces. I know now that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. So since the triangles are the same size, all of their pieces are the same size. So the piece that I didn't know about, I didn't know anything about A and C, and now I do. I know that A is congruent to C now. I also know, let's stick with the angles, I also know that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2 because if those 2 triangles are the same size, then their parts have to be the same size. Corresponding parts of congruent triangles are congruent. And then lastly, so I have two sides and all three angles, so I need one more set of sides. I know lastly that AB, segment AB, is congruent to segment CB. So I use three pieces to prove that the triangles are congruent. And once the triangles are congruent, I use CPCTC, corresponding parts of congruent triangles are congruent. So the corresponding parts are congruent if the triangles are congruent. That's what that stands for. Okay? So let's look at another one. AB is parallel to DC. Let's see what that means to us. Why would we need that? AB is parallel to DC. Now the reason that I need that is because it gives me that angle 3 is congruent to angle 1. Okay? Angle 3 is congruent to angle 1 because if lines are parallel, then alternate interior angles are congruent. I also know that AC is parallel to DB. AC is parallel to DB. Now, why that's important is I have that transversal. That tells me 2 is congruent to 4. So now I know that angle 2 is congruent to angle 4 because if lines are parallel, then alternate interior angles are congruent. Remember, every statement is going to result in something being congruent to something. So I've used up all of my givens. I got to look at my picture and I got to see what else I know. The only other thing I know is that AD belongs to both triangles. So I also know that AD is congruent to AD. So let's mark the pieces we know. Mark only on one of them, right? Angle 3 is congruent to angle 1. Angle 2 is congruent to angle 4. And AD is congruent to AD. Now look at where that is. If we just look at this, angle A, I have angle A, I have angle D, and I have side AD. That means that side AD is included because it's made up of the two angles that I have colored. So ABD is congruent to D, triangle DCA, because of the angle side angle theorem. Prove the triangles are congruent, then talk about the rest of the sides. Now that I know that those two triangles are congruent, I can also say anything left over. I have one more angle that's missing. I can say that angle C is congruent to angle B because they are corresponding parts. I have that angle, or excuse me, that side AC is congruent to side DB. Side AC is congruent to side BD. And side CD is congruent to side AB. Because once I know that the triangles are congruent, I can say that the corresponding parts are congruent. That's when we use CPCTC. So CPCTC in a proof always follows after the SSS, SAS, ASA, AAS, or HL. Okay, it has to come after I have said that the triangles are congruent. You won't use it before. So let's look at a couple of proofs like this. Let's start here. C is the midpoint of AD, and C is the midpoint of EB. Again, the reason that I always know that first statement is because it is always given information that I have been told. Now, statements like this always result in sides being congruent to sides or angles being congruent to angles. Point C is the middle point of segment AD. So point C is in the middle of AD. That means AC is congruent to CD. That's what this means. And BC is congruent to CE. That's right here. That is the definition of midpoint. Midpoint, definition of midpoint. It always works that way. You notice, always works that way. Midpoint means it's the point in the middle. So C is the point in the middle and C is the point in the middle. Okay, now, I've used up all of this, right? These two resulted in these two statements right here, so that's all there is. ACB is congruent to DCE. So I look at my picture, I mark that on my picture, and I look at my picture. Why do I know that? It's not because of either of these two statements. Those are midpoints of segments. Why do I know those two angles are equal to each other? Because they're vertical. And we know that vertical angles are congruent. Now, I have three pieces, right? I have a side, I have a side, I have an angle. So let's pay attention to the order that they are in. I have a side congruent to a side, I have a side congruent to a side, and I have an angle congruent to an angle. That angle is included between those two sides. I have side AC, side BC, and angle C. So since it is included, then it is side, angle, side, because the angle is being included between the two sides. I have just said these two triangles are exact same size. Based on three pieces of information, I have said that the triangles are the same size. Now I can talk, just like we did over here, I can talk about any three of these pieces. Now, the leftover pieces, I can talk about all the rest of them. I have one more side pair, because here's one side, two side pairs. I have one more side pair I could talk about, and I have two angle pairs I can talk about. But I want to talk about this one in particular. Now that I know that the triangles are congruent, I can say that angle A is also congruent to angle D because corresponding parts, CP, of congruent triangles, CT, are congruent. Corresponding parts, A and D, are corresponding parts. They belong to, this is my CP, right? That's my corresponding parts. These are my congruent triangles, and here's my congruent part. Here are my corresponding parts. Here are my congruent triangles, and here is my congruency. Okay, that's what that stands for. You cannot use this. CPCTC will never come before SSS, SAS, HL, those things right there. Okay, they will never come before. You cannot say that the corresponding parts are congruent until you have said that the triangles are congruent. Okay, now let's look at this. Let's take our pieces. Remember, statements that don't already say that something is congruent will always result in something congruent. So always look the next row down. So these two are parallel, should create that right there. It should create that. So let's look. Here's angles congruent to angles. Let's mark our givens. So angle R is congruent to angle T. That was given. I know all of this first statement because it's given. It's always going to be given. Nobody should ever miss statement number one and reason number one. Again, every statement that's not a congruency statement will result in the next statement. So QR is parallel to TS. Let's look at that. QR is parallel to TS. And I have said that RQS is congruent to TSQ. The reason is because of those parallel lines, the statement above. The reason is because if lines are parallel, which I said they were right here, I said those lines are parallel. And if lines are parallel, then I know, then alternate interior, shorthanding that, alternate interior angles are congruent. I said the lines are parallel, therefore I know the angles are congruent. There's another pair of angles that are congruent. You mark these so they look different. Then, now completely separate, I used this to get this statement. I already had that statement. Now we're starting fresh. We've used up all of our givens. QS is congruent to QS. Let's look where that comes from. QS is congruent to QS. Well, QS is reflexive. Anytime something is congruent to itself, it sees its reflection It is the reflexive property. Okay, it is the reflexive property. Now I have a side. So I have two angles and a side. The question is it angle, side, angle, or is it angle, angle, side? We need to go over here and we need to mark our pictures just like we have been the whole time. Okay, I have an angle congruent to an angle. I have another angle congruent to another angle. And I have a side congruent to itself. So look at those orange markings and only the orange markings. This orange angle is hanging out here all by itself. This orange angle is touching that orange side. That means this side is not included, right? This is what angle, side, angle looks like. This is what angle, angle, side looks like. Okay, so that fits angle, angle, side because it's angle T, it's angle S, and it's side QS. Angle T is not included. So it is angle, angle, side. Now from there, I have this angle Q is equal to that angle S. I have this side congruent to this side, this side. I have all those things, right? I can talk about all 6 pieces now that I have. I've named 3 pieces. I could name the other 3 pieces, but I don't care about all of the other pieces. I only care about QT is congruent to RS. If QT is congruent to RS, then that is because corresponding parts, these 2 parts, QT is congruent to RS because corresponding parts of congruent triangles, I just said they were congruent, of congruent triangles are congruent. Those corresponding parts are congruent because those triangles are congruent. CPCTC will, if you have a congruency statement after proving triangles are congruent, it will always be CPCTC, always. I can use CPCTC after proving a triangle is congruent to a triangle. You cannot use it before. You have to say that the triangles are congruent, and then if I say the next statement is congruent parts, then it has to be corresponding parts are congruent with congruent triangles. CPCTC.